Good evening. Tonight we are solving for exponents. So you're going to see equations that have, for exponents, variables. The bases will be known values, but the exponents will have variables. So the basic concept we're going to be using here is that if A equals B, and if A equals B, and if A to the x equals B to the y, then x must equal y. So if we have two bases that are the same, and each of these bases has an exponent, therefore the exponents must also be the same. That is the basic concept we're going to go back to time and time again. So if I'm given this equation, 5 raised to the 3 minus 2x power equaling 5 raised to the negative x power, since these bases are exactly the same, then it is also true that 3 minus 2x equals negative x. And from here, I can solve for x using my OPE theorem. Adding 2x to both sides gives me x equals 3. Okay, but all this was made possible by the fact that these two bases were the same. If this said 5 and this said 6, then there's no way I could have written that equation. Okay, let's try that again over here. So if I have 4 to the 2p on the left, and on the right 4 to the negative 2p minus 1, since the bases are the same, I can say that 2p equals negative 2p minus 1. Add 2p to both sides, and p equals negative 1/4. Okay? Now we're going to have situations where the bases are not the same, but there's still something we can do sometimes. So the bases are not the same. So I may not write that. That's not true, because these bases are not the same. But 8 and 2 do have a relationship. 8 happens to be the cube of 2. So I can rewrite 8 as 2 cubed. Now the base is 2. Over here, the base is already 2, so that's good. And that 2 cubed, which used to be 8, is still raised to the x minus 1 power. So now my equation looks like this. I'm getting closer and closer to a situation where I have the base is the same, the base is the same, the base is the same. So I have an exponent on the inside here and an exponent on the outside, so that allows me to use power to a power and rewrite this as 3 to the 3x minus 3, distributing that 3. Now I have the same situation I had up here and here. So now I may say that this exponent equals this exponent. And then solve. Okay, so just to recap, when the bases are not the same, you don't just give up. It's possible that you can rewrite one of those two bases in terms of the other base. And in this case, the 8 can be written as 2 cubed. So now I have the same base. And then I just need to get rid of the parentheses by using power to power. Once I get the same base with no parentheses, I can make the two exponents equal to each other. Okay. Now in this case, 81 is not a power of 27, nor is 27 a power of 81. However, both of these are powers of 3. This is 3 cubed, and this is 3 to the 4th. That means I can rewrite both as 3 to some power. 27 I will write as 3 cubed. 81 I will write as 3 to the 4th. Now I'm going to use my power to a power again, rewrite the left as 3 to the 3x, power to a power here, rewrite this as 3 to the 4x plus 8. Parentheses are gone, so now I can equate these two exponents. X equals -8. Okay, I've got one more. Okay. 512 is not a power of 16. However, 512 is a power of 2, and 16 is also a power of 2. So I'm going to rewrite 512 as 2 to the 9th, and rewrite 16 as 2 to the 4th. Now I can simplify the left, power to a power again, 2 to the 9x. And the right, I can't leave it as a fraction, so I'm going to use the negative exponent rule backwards and write this as 2 to the -4. Alright, I got the same base, I don't have any parentheses, I don't have any fractions, so now I may equate the exponents. And x is -4/9. Okay, so to sum up again, make the bases the same, use power to a power if you have to get rid of the parentheses. Make sure you don't have any fractions. Once all that is said and done, make your exponents equal to each other. Okay, see you next time.